Welcome back to Lumicore Labs. Day 11. Up until now, each variable we've created has held a single piece of data. One name, one number, one Boolean. But what if you need to store a whole collection of things? A list of students in a class? A playlist of songs? A shopping cart full of items? That's where lists come in. Lists are Python's way of storing multiple values in a single variable. Today, we'll learn how to create them, access items, change them, and use their most powerful methods. Let's get organized. Let's start by creating our first lists. An empty list is just two square brackets with nothing inside. This is how you start when you want to add items later. Here's a list of 4 numbers: 10, 20, 30, 40. All integers, all separated by commas, all inside square brackets. This is a list of numbers. This is a list of strings for fruits. Notice the quotation marks around each item. Python needs these to know their text. See this mixed list? It has an integer, a string, a float, and a Boolean all in the same list. Python allows this. In practice, though, most lists contain items of the same type: all numbers, all strings, all dictionaries. It makes processing them much simpler. When you print a list, Python shows it exactly as you wrote it: square brackets, commas, everything. This is helpful for debugging because you can see the entire contents of your list at a glance. Let's look at how to access individual items inside a list. I'll create a list of 5 fruits. Accessing items in a list works exactly like strings. Fruits brackets 0 gives us the first item. Python starts counting at 0, not 1. So index 0 is apple. Fruits brackets 2 gives us the third item, cherry. Negative indices count backwards from the end. Fruits brackets -1 is always the last item, elderberry. Fruits brackets -2 is the second to last item, date. Very useful when you want to grab something near the end without counting how long the list is. Now slicing. Fruits brackets 1:4 means start at index 1 and go up 2, but not including index 4. That gives us items at indices 1, 2, and 3, banana, cherry, date. The original list is unchanged. Each of these prints shows exactly what we asked for. Index 0 gave apple. Index -1 gave elderberry. The slice brackets 1:4 gave a list of 3 fruits. Slicing is incredibly powerful. You can grab any portion of a list in one line. Unlike strings, which are immutable, you can't change a character in place. Lists are mutable. You can swap out an item just by assigning a new value to its index. You can add items with .append, which always adds to the end, or .insert to slip an item in at a specific position. This flexibility is why lists are the workhorse of Python data structures. I'm replacing green with yellow directly. Just assign the new value to the index. Simple and powerful. You can change any item in a list this way, no special function needed. .append adds to the end of the list. .insert Index, item, adds at a specific position. Here, I'm inserting orange at index 1, so it becomes the new second item, and everything else shifts right. The list grows automatically. You don't need to declare a size up front like in some other languages. Removing items has several flavors. .remove value deletes the first matching value it finds. .pop does two things. It removes the last item and hands it to you. I'm storing the popped item in a variable called popped. This is perfect for undo operations or for processing items one at a time from the end of a list. You can also give .pop an index to remove a specific item. Del is for when you know exactly which index to remove and you don't need the removed value back. Clear is the nuclear option. It removes everything at once. Be careful with clear. Lists come with a toolkit of methods. .sort modifies the list in place. It doesn't return a new list, it changes the existing one. If you need to keep the original order, make a copy first. .reverse flips the current order. Len is one of the most used functions in Python. It works on strings, lists, tuples, almost any collection. .count is handy for seeing how many times a specific value appears in your list. and .index finds the position of an item. These methods make data manipulation a breeze. Day 11 is complete. Lists are the backbone of Python programming. You'll use them in every project from now on. In the next video, it's practice day. You'll solve list challenges that test everything you learned today. Hit the like button and subscribe to Lumicore Labs and tell me in the comments, what's one thing you'd store in a list right now? See you on day 12.